Okay, so this is the research meeting from Friday, excuse me. I went through, and Lucas, who's presenting on this, gave me a bunch more information, notes about related papers. Specifically, this lottery ticket hypothesis is apparently a hot topic in the machine learning world right now. Good morning, Falco. Good morning, David. Sorry, David, you're excited we're doing spatial pooling? Is that what the woo-woo was for, or are you just saying hi? I have to apologize to you guys ahead of time. I hurt my neck over the weekend moving a ping pong table. And I haven't quite recovered. I'm having a hard time turning to the left and looking up. So at some points during the day, I'm gonna be taking some stretching breaks. And I'm gonna try and drink a lot of water. Remind me to stretch. I'll probably be reminded by the pain. Anyway, there's, did I put this? Did I put the link in here? Let me do this. Anyway, here's the recording of the research meeting from Friday. That was a good research meeting. This seems like a great opportunity for HTM inspired ideas to work in a machine learning system. So I think I'm pretty excited about this. I mean, if we can make a nice impact by, I don't know, breaking some benchmark, performing really well on some benchmark, especially with noise involved, we could maybe get some recognition and more people looking into this technology because so few people are currently paying attention. Hey, my chat came back. Hold on a sec. I'm sorry, I gotta try and fix this. Okay, hold on. I swear, there it is. So usually if I just open it and close it, it goes back. Oh. It went away. Where did it go? Where did it go? That's so stupid. It like changed size. Okay. I'm getting it. I don't know how it changes. Now it's gone. I don't know what happened. That's so weird. It was there and now it's gone. Now it's super small, but it's still gone. All right, anyway, on with the previous solution. Anyway, I'm gonna look at some forum stuff here. And I'll take totally random questions. This is sort of the casual chat part of my stream before the research meeting where I'm just sort of arranging things, chatting with the community. You can see how freaking stiff I am when anyway, let's go to my screen, yeah. And I'm gonna talk about some forum stuff. Okay. So yeah, we had a great Hackers Hangout. I don't know if any of you were there. We do our Hackers Hangouts on YouTube, not Twitch. So in case you're just watching Twitch, here's a link to this thread on our forum. And we had a good Hackers Hangout with several people join. Here's the link to that video. Always sending you all the links. And so there was some discussion about this Hangout. We had Marcus, who's one of our researchers on a research team, our primary researcher aside from Jeff at the moment, that's researching like sensory motor integration type of stuff. He was online during this video and took a bunch of questions. There he is.
Stream.
Anyway, Marcus is great. I was very happy to have him on. So he took a bunch of questions. Falco responded to him. So yeah, there's a lot to think about. There's a lot still to do. And then Gary, I read through this. I have to admit, I was not keeping up with the discussion on the neurons antenna. So I wanted to look into this. And if anybody else was, let me turn Discord on. Let me join Discord chat. I mean, if anybody wants to chat with me. Here, let me send the Discord link. I'm gonna get on voice chat. And I may want to turn this music down if I'm getting on voice chat. So anybody's free to jump on voice chat if they want. Because I wanted to have an understanding of this idea of neurons' antenna, and I think there's, whoops, darn it. I don't think there's, I just pulled some, that's not what I wanted to do. Okay, so this idea of neurons' antenna is, I think, a familiar idea for me. I don't, but I just wanted to understand, I didn't read the paper. The widespread, I have not read this paper yet, but the summary says, so we're talking about dendritic synapses, and one of the key parts of HTM theory is, in sequence memory, the temporal memory part of it, is this idea of how distal dendritic segments are what they're there for. And I think that's what they're relating this to, you know, as treating these distal dendritic segments as calling them antenna, because I think they're far away. It is sort of like an antenna array, you know, except we're not looking for light or signatures. We're doing pattern recognition everywhere. So I think that's basically what this paper is saying. The recruitment of active dendritic processing, that's what we call dendritic spikes. They, or active dendrites. I think the neuroscience community is starting to call them active dendrites. And its relationship to somatic activity remained poorly understood. I don't know. At a high level, I think we understand it. I think we're the first ones to understand it. And that was what the paper "Why Neurons Have Thousands of Synapses" is all about. So they are monitoring dendritic and somatic compartments in the awake primary visual cortex, looking at layer 5 pyramidal neurons, somata, and distal apical trunk dendrites, show surprisingly high functional correlation. Yeah, so like that, probably because the distal dendrites are predictive of the neuron action potential. This strong coupling persists across neural activity levels because it's a core function of the cortex. That's why. You're doing temporal prediction constantly as you're modeling things and like moving through spaces. That's what this is even if you imagine moving through a space, this is happening. Contrast to the view that dendrites are only sparsely recruited. So yeah, I think this is just saying, are there any big ideas coming from this? Sure, so we're saying antennas work. I mean, it's a good analogy. It works for any type of sensory input, I think. This should be happening in all cortical areas. Okay. Oh, I'm gonna write this voice chat open in case anybody wants to join. So Gary was commenting on this, and I think he got, from what I read in this, he got some insights. So let's read this. The grid cell alternating back and forth in time. I'm gonna see what video he was referring to here.
They found that the activity was kind of alternating between how the cells used to fire and how they are. So imagine rats in a room. There are rewards spread around the room in these consistent places. But then an hour later, those places are rearranged. Now the rewards are placed in different locations.
For more info on this, watch our Hackers Hangout that I linked to earlier. So he's referring to that alternation. So essentially, you learn a room, you learn where the rewards are in the room. You know you come back to the same room. So there's some identifying feature of the room. You come back to the same room, but the rewards are all in different places. So over time, as you experience these two different situations in the same room, you create, I guess, different grid cell activations. Well, what he's saying is even though it's the same room, you've created two different mappings of grid cells onto that room. One for one reward, arrangement one for another. So you're like tricking your brain into creating two maps of space, right, for the same place. And this idea of it's not really tricking your brain. I think your brain just does this. But this is sort of the trick to make it do that, you know, is this experiment. It's a really interesting experiment. So, okay, so the grid cell alternating back and forth in time, when like the animal needs to sort of refer to both of these representations, I would say. So he's explained is the same as in the ID lab, where I found this as in a union merged previous blobby experience from two reference frames into one that takes into account directional movement. Okay, I haven't seen Gary's work in a while. Gary makes these really cool, like life simulations. They're really neat. Like this. This is pretty amazing. Let's watch this too, because why not? There's no sound to this, so if you guys want, I'm gonna use the restroom. At least I'll have something interesting to look at. You looked confused just then. Okay, sorry, I tell you guys to chat with me and then I ignore the chat. So we're sort of pooling and then brain having to choose between the real-time input. Yeah, it's I wouldn't be surprised, like if you think about simultaneous predictions, it's sort of similar, I think, to simultaneous predictions. You can simultaneously keep two competing concepts in mind at the same time until you gather more information and then one falls away, I think. I wonder what he used for his hex representations. He did all this in an old version of .NET, I think. It's like VB.NET, right? Gary, if you're watching on YouTube later, I'm pretty sure this is all done in VB.NET. Check the post, he mentions it on the forum. You can do, this is so cool though. I love this visualization. I don't quite get the hexagonal thing at this point, but I think what his point is, he sees the same phenomena in the system he created. This thing's got goals and everything. Like you see, it's going to get food and it stays out of the parts that hurt it. It's got all these sensor arrays. All these little things around it are sensors. Such a cool experiment framework, you know. It's such a cool little environment. I wish it weren't in VB.NET. Gary, do you have any plans of porting this into something, I guess, more useful to today's programming environments? So he was referring back to that. He found that this, as in a union merged previous Bobby experience from two reference frames into that, takes into account directional movement of the zone. This way senses how close it is in space and time to getting zapped again. This gets back to an earlier challenge you propose to use HTM to learn a 2D environment. Yeah. Remember when we were doing that? That's what I started doing on Twitch. I still want to come back to that because I think that's still fun. And I think we can build it. So where we left off, I was expecting to become easier to just include the alternating between time frames part than watch it go on its own. Wait, alternating between time frames. Right, alternating like representations of where it's at between time frames. So when we do, because this experiment that we're going to do, at least I'm pretty sure that we're not going to see that, because at least I don't think that when we originally did this experiment we saw it, but it's a very simple experiment, and I think we might be able to get probabilities of like which environment we're supposed to be in. Hello Fixable, thanks for following. It's much appreciated. Talking about brains, do you have any questions about brains? We're trying to, we had a hackers hangout. I don't know if you've been watching or not. And the discussion is like all about the representation of space and orientation of objects, space around objects, how they're oriented. How we can, this is my crystal. I'm not a metaphysical person, but I love crystals. How we can represent objects in space anywhere we want, have this, what's the word for it? Not allocentric, that's location, but like there's a word that means one and only one. I can't remember what it's called. That's used in computer science and like AI. But we have this unique representation of objects, and they all are represented within, this is part of key to the HTM theory that we propose at Numenta, is that they each have their own reference frame, they each have their own area in space where we take sensory input that we perceive or in that frame, and we sort of like attach it in locations relative to each other. And we think we use grid cells to do that because that's sort of the brain's mechanism that we've found that happens to work in the hippocampus, and we've seen evidence of it in the neocortex as well. So we know there's this type of mapping happening, or at least this representation of space. There's a way your brain represents three-dimensional space, two-dimensional space, probably any dimensional space, and it's probably using this grid cell mechanism. And using this mechanism, we can theorize about how objects can be constructed out of other objects. Super fascinating stuff, the way the brain works. Thanks, Falco, for the explanation. We've been doing this at Numenta for almost, I don't know, I've only been doing it for like 8 years, but the company's been around almost twice as long. And the goal is to figure out how the neocortex works, what is it that makes the neocortex intelligent, and how can we create systems that are intelligent in the same way. Lots of progress that we've made you can find at numenta.com/papers. Okay, so I was just reading the forum. That's another topic if you're new. We have a forum with lots of friendly people. If you have any questions and you're afraid to ask me on Twitch or whatever, you can just post a message on the forum and somebody will help you out. Okay, so we're back to this 2D object recognition challenge that I was working on when I first started Twitch that he's referring to. And like I said, I don't know that we're going to have that problem, but I think we might be able to at least select what environments are most probable based on a couple of movements. Okay. Then have to write code to manually control all that extra code in HTML algorithm to compensate for not having full control of its body. In that case, it would also be a 4-sensor antenna dendrite starter model. 4 sensor. So this is a little more detailed than I thought. Maybe I don't quite understand that, because I hadn't actually read all the way to the completion of this thread. He says where it went to. Oh, now we're talking about bidirectional spiking. Bidirectional. So bidirectional in the sense that that learning is occurring. Yes, but maybe. But I'm not sure what more to say about that. The only information going the other direction is whether the prediction helped, right? Because the dendrite has to know if if a dendritic spike occurs, all of those segments that contributed to the dendritic spike need to know whether that correctly indicated the firing of the soma, so that they can increase their permanence values, increase their synaptic weights. But I think that's the only bidirectionality I can think of. It's not like the neuron is communicating in the other direction to the neurons on the other end of those connections. Directional refers to motion of stimuli, not spiking. Yeah. The directionality of spiking. So spiking doesn't go the other way, as far as I can tell. I've got a very stiff neck today, so forgive me. It's not clear if the postsynaptic feedback is only diffuse inhibition or if there are also synapse-specific excitatory spikes. Synapse-specific excitatory spikes. I don't entirely know what that means. There was this found in their model that indicates spikes initiated within local dendritic regions, traveling both ways through their respective dendritic tree. Maybe there is evidence of this, it's just I haven't seen any. Our simulations show that sub-threshold PSPs from the distal dendritic regions, I assume these PSPs are NDMA spikes, postsynaptic, PSP postsynaptic something, from the distal dendritic regions on the on-off DSGC, I don't know what that means, are heavily attenuated by propagation to the soma. Heavily attenuated by propagation to the soma means affected if, but that spikes initiated within local dendritic regions, dendritic spikes, right? Or are we talking about somatic spikes? I don't know. Can propagate with high probability to the soma, must be dendritic spikes, to the soma and back propagate to the remainder of the dendritic tree. I've heard about this before. I've heard them talk about this in research meetings a long time ago. So it's not just the originating segments of the dendritic spike that get information about whether the cell fired. The entire dendritic tree does. Therefore, active amplification of DS, which I think means dendritic spike, appears to take place during spike initiation in the dendrites. So when the soma fires, there's some indication back to the dendrites that it has fired, which makes sense. This seems close to what you're describing. If inhibition is optionally included, then back propagation can be stopped. This isn't the back propagation. Oh yeah, here we go. Thanks, but it's weird that back propagation is to remainder of the tree. It implies that adjacent but not spike-causing synapses are potentiated. Adjacent but not spike-causing synapses are potentiated. Fire together, wire together would be reinforcing the spike-causing ones. Here's Mark Brown from Jordan. Weird idea keeps coming to me that it is the fire together, wire together thing is partly or wholly a local thing based at the synapse level. I envision a mechanism where the products of the metabolism of firing interact with the extracellular chemicals to promote growth. I extend this with the thought that some residue of this experience, a metabolic residue, makes the synapse susceptible to the soma-based firing wave as the local back prop training wave, as envisioned by Demento. I think that makes sense, man. Does that make sense? Okay. I think I'm understanding this. Am I missing something? Because this type of back propagation that we're talking to, I don't think it's it's not the same type of back propagation that we talk about in neural networks, because that's going throughout hugely deep hierarchies We're talking about backpropagation of information within local areas, and I think that's what King is sort of pointing out here. Now this extension, that some residue of an experience makes the synapse susceptible to the soma-based firing wave. Yeah, that's sort of how learning occurs. Yeah, I think that's right. Okay, the new RNA-related information just arrived. Oh, this is a new. Scientists found out how nerve cells can pass information down several. Is this a? I haven't seen this up. This is just like brand new. This is a science alert. I don't trust this right away. I think we need a paper, right? Brain's activity doesn't influence the physiological development of your sex cells. What do you think can't be inherited? But now it looks like we may need to rethink this. Nerve cells can pass information down several generations. Okay, I'm not certain this is related. At least we're not thinking about this at all. So Gary says, don't stop there, keep going. Almost everyone reading this is probably wondering, backprop, training wave, what? Yeah, it's not like backprop in deep learning. Best I can do is recommend asking BitKing for more details. I already read this. This is a great explanation, I think. I'll let you guys read it yourself if you want to. I think I've already got links to the forum in there. Let me read this again. The predictive model assumes that some part of the dendritic arbor fires on a sensed pattern, making the prediction that we will fire again soon. The prediction is a partial depolarization, but not a firing of the main soma. This prediction is central to HTM. Later, but not much later, the main soma fires a big event on the cellular level, and the action potential fans out through the output axon and back up the dendritic tree. That's the point. That's how the dendrites learn. The backpropagation wave that we're calling it here. We never call it the backpropagation wave, but you could call it that. HTM theory has an assumption that the synapses that predicted this firing are strengthened, and this is a key element to the theory. Exactly. Now I'm wondering why there's no online HTM neuron in a dish. Yeah, I don't know. So I'm trying to get to the point where we were talking about. Okay, yeah, back to this one. In the case, there would also be 4 sensor. So this is what I'm trying to get to. The 4 sensor antenna dendrite starter model. Where is that? With all the theories being to some extent tentative, it should at least. Hey, thank you for the follow. Be rousing. I appreciate it. I'm just reading forum right now, but I will be doing some more interesting things soon. I'll be streaming all day, most likely, for the next 4 or 5 hours. What is this? Yeah, so 1,000 Brains absolutely depends on HTM, the old stuff. With all theories being to some extent tentative. No, I don't think so. The basic sequence memory of everything is built on that. That is not tentative. That is something that we're pretty certain is going to happen, or is happening. Basically, this paper that just came out. When did this come out? 2019, days ago. We wrote about this 8 years ago. So, like, we published our first white paper, basically explaining this 8 years ago. And that is like core to HTM theory. That is not tentative. I think that's like, if that doesn't work the way we think it works, we're on the wrong track. Because everything we do is like based on this idea. All of our sensory motor theory, all of it is based on that idea of temporal sequence memory. It should be this early point in time, be no problem to where need to take HTM right out. Wait, it should be early. It only needs to, somewhere in the cortical mass, be found a whole bunch of smaller brains with the moving straw fields of the outside world. In fact, I was quietly hoping that the theory would end up needing to include at least some of the individual neurons. In that case, TBD only becomes even more awesome. I'm confused. I'm a little confused, Gary, by your thinking on this. I need like a sound or something whenever there's a chat, because I keep missing chats. I'm gonna see if I can turn that on. No, apparently not. Anyway, we'd be interested in finding out how inhibition works in the brain. I mean, well, you mean how it works, like specifically with like what cells exactly are doing what? I think there's a lot of papers on that. So I'm confused. I'm gonna quote this, and I'm going to push back a little. I wouldn't say this at all. The sequence memory algorithm we see okay, I'm gonna just leave it. I think that's true. Sequence memory algorithm we explained in our 2011 white paper is essential to all further Nementa theory. If it doesn't work out, if we find that this model is inaccurate, if we find we will have to rethink all of the, let's call it sensory motor theory and TBD. Okay, I'll leave it at that. Doesn't inhibitory neurons regulate sparsity? Yes, they do. And we'll talk about it. Well, I was just talking about it actually, and there was another thread. Where were we talking about that? Oh. Are we just talking about this? I know I just posted about it. Here it is. Oh yeah, let's talk about this. This is so cool. Okay, so Marty, maybe you're not online, but I know you're probably watching later. I'm super excited by all the work that you're doing, and this in particular is awesome because it validates. Because I know you're writing your own systems and you're finding the same things that we're finding, and I think this can potentially be really valuable to the machine learning community if we can figure out how to apply it to a real problem right now and like change the game for some industry, you know. So this is awesome. So he's basically taken the things we found in our paper, how can we be so dense, which is attempting to take aspects of spatial pooling and apply it to deep learning networks. You can see all of this in this thread if you want to read it. But essentially, this is the direction like part of our research team is going right now. We're trying to figure out how can we apply HTM ideas to deep learning networks. And what Marty's done is basically validated the theories in this paper that we've run, and showing that using a K-winner activation in addition to boosting is really, really good. And we're like, yes, great. Because with noise, particularly, it's really good at defeating noise. And that's something deep learning networks are not very good at. So like we're talking, you know, these types of numbers, recognition, pattern recognition, no, this is noise accuracy. I think it's pattern recognition accuracy, classification accuracy or something, that are really low with typical CNNs, but when we add this instead of doing a ReLU activation, we'll do a K-winners and also enforce potential pools with initial weight settings and run this boosting, which means that you have to run this at each time step if you want to get really good numbers. That's the problem, because currently deep learning doesn't allow you to do that very easily. To run processes after each data point, you usually glom together thousands of data points and run this huge cumulative mathematical function over it to find the, what do they call it? The do basically linear regression. That's it, linear regression. But this isn't really doing that. We're taking like one step at a time. We're learning every time. That's quite impressive. Okay, so this is very cool. Very cool, and he's saying that like when you add boosting to this, because it's not just K-winners, because K-winners won't do this by themselves. But with boosting, that's like the secret sauce, because you have to take this, and we're gonna get to boosting in building HTM systems at some point too, and I think that would be a good visualization, is if we show a histogram of knowledge representation or active duty cycles, let's say, a histogram of the active duty cycles, which is basically how active mini columns are over time. And without boosting, you can see that there's these mini columns that end up representing so much of the data, because mini columns have a high capacity. These structures that we're creating have very high capacity for sequence learning and for spatial representation. So those mini columns can represent a lot. So they do. When you let them just run, the first ones that win just keep winning on all the patterns. So what the boosting does is it like squelches them down, it pushes them down. It's like, okay, you guys are too active. We're not going to let you represent this new pattern coming in. We're going to randomly pick something, another mini column. And this is happening in your brain too. I mean, this is brain inspired. This idea of homeostatic regulation is completely brain inspired. Boosting's like not accelerating this. Accelerating the strengthening of it's like it's not artificial. I mean, this is what's going on in your brain. It's this it's part of the inhibitory. I think it's I did a video on boosting, and I pointed to a paper that I was reading. So I would go there. I can probably find it. HTM school boosting. That's the boosting one. Now in Chinese.
Well, it's been
Okay, so there's all these, I did all these graphics about boosting. And you can see with and without, where's the active duty cycles? Here we go. This is with boosting on, they're all spread out. And with boosting off, you get like only a few of them are, wait, I might have been backwards. Anyway, where is the link? I had a link to it. Maybe I didn't have a link. It was just a Wikipedia page, sorry. Homeostatic regulation of neuronal excitability. That's what it was. Homeostatic regulation of neuronal activity. Excitability. Excitability. There we go. Scholarpedia. Anyway, when Yue used to work here, he explained this all to me. Yue is a real hardcore neuroscientist. Like he's a PhD of neuroscience. He worked in a wet lab with monkeys for before he came and worked with us. So he seemed to know what he was talking about, and he knew what this was. He's like, yeah, he explained to me how it worked in the brain, not in our code, but. Okay, I need to get up and stretch. Like I said, I injured my neck over the weekend moving a table tennis table, and I need to stretch. I'm glad you guys enjoy the puns in the HTM school. Some of them took quite a while to come up with, believe it or not. It feels like a leg cramp in my neck that won't go away. It's like a neck Charlie horse. All day yesterday, it's awful. If everything goes well, oh man, if I can still move by the end of the week, I should be able to have something fun to show. I got a new guitar. I know that's super exciting to all of you. I will show you the guitar. Hopefully Friday. I'm hoping it shows up on Friday. I've had my saxophone in consignment for months and months and nobody would buy it. And yesterday, my wife comes home and she's like, "You got this check from Village Music," and they had sold it and just sent me the check. And I'm like, I can get the guitar finally. I've been waiting for a long time to get this guitar. If you look back at my tweet stream, I was tweeting about it a long time ago, but the saxophone never sold until yesterday. So that's super exciting because I've been wanting this. I've been wanting a decent electric guitar for a while. And this is an American-made Stratocaster, brand new. I'm just super excited about it. And it's beautiful. Young-Sung-go, bye. Have a good luck on your exam. Get some sleep. Probably up too late. Okay. Let's look at simple HTM a little bit. Let me make sure I didn't miss anything I wanted to talk about here before we go. We do this. Oh man. Oh yeah. Let's look at this. So another thing, community-wise, I noticed that Richard Crowder. Hey Richard, are you there? Is anybody there? I can't tell. My chat's a little bit broken, but Richard is a lot of times in chat. His name's Rick Rowe on Twitch. Forgive me. I hope this doesn't hurt my neck. I'm about to sneeze. Oh boy. God dang it! Why does that happen? It didn't happen. I feel like really let down now. Because I wanted that sneeze, you know, and you feel like it's about to happen, and it didn't happen, and now I'm depressed because I didn't get to sneeze. Anyway, where were we? Yes, here's what I wanted to show. So I was looking at eTailor, which is Marty's new HTM implementation in C++, parallel C++, optimized for parallel and GPU. You highly recommended this travel guitar? Okay, I'll take a moment to look at your travel guitar. For kids and smaller fingered people. You know, Yamaha makes a good guitar. Even their cheap guitars are good. That's nice. I have my primary acoustic guitar is a Yamaha. I don't want to show my email, sorry. So anyway, Richard Crowder has updated eTailor so that it can build using Microsoft Visual Studio. So I am wondering if this is going to help me. Oh man, my neck hurts. I'm wondering if this is going to help me because I've been having trouble building it. So we'll see. I'm watching this. This is great that you guys are working together. Marty Richard is a great guy for helping out. He's really helpful for us when we were doing C++ stuff in NewPick. So I just wanted to point that out. That's cool. Let's see. Okay, let's look at simple HTM now. And I'm gonna have to I'll give you the link, and then I'm gonna have to open my window because I'm getting super hot. Technically, I'm overpressed because of the missing sneeze. It's a pretty hot day. Yesterday and today were pretty hot here in Watsonville. It's supposed to be, well, I mean, hot for Watsonville. All right, so I'm going to, I have a copy of this locally. And I'm just gonna peruse around in here. Oh, I really wish I could still sneeze. I'm in building HTM systems, so I don't want to be in there. Simple HTM. So before I do anything, guys, is it like obvious that my neck is not turning? Because I'm like this, so just move my whole chair. Upstream, upstream. I think everything's up to date. I should be able to run tests. They all passed last time. Okay, great. Let's see, what do we have here? 23 tests. We don't have anything for spatial pooling at all. I'll go ahead. I don't know what I'm going to do here aside from just perhaps set the stage. Because what I want to do is, if you guys remember our last BHTMS session, we were working on potential pools and initial permanence values. At this point, I want to create a spatial pooler class, and this is, I've been thinking about this, and I think it should be pretty functional. Relaxing my jaw. I'll try. How do I do that? I just shove something in there. Whew. Okay, so I'm going to create a spatial pooler and some tests, specifically around the potential pools and the initial permanences. And then we're going to swap out whatever we implemented in simple HTM to run building HTM systems visualizations, the potential pools and permanences. So right now for these, if you followed along with me last week, these are all just sort of local calculations. They're not attached to anything. Each diagram, I believe, is keeping its own state. So we're gonna lift that up out of the diagram state and we're gonna keep it somewhere else. And we're gonna use a spatial pooler class for the logic there. Now, there's a lot of ways we could go about doing this. I'm in favor of keeping it object-oriented. I am not necessarily in favor of mutable functions. So I think we will try and do a hybrid object-oriented functional approach here, which is sort of what Nupic does as well. And I never liked how it did it until I thought about doing it myself, and now I want to do the same thing. So basically, we're going to have a spatial pooler class, and we want to instantiate it because we want to keep some track. We want to keep track of some state, like how many records we've seen, potentially other things. But I want to make all of the functions as much as possible functional and immutable. So you pass it in arrays of data representing the input and an empty array essentially of what the active mini column activations are, which are empty. And it basically populates your array. So that's what Nupic does. We don't have to do it just like that. But the point is that we're not going to maintain all of that state, initially at least, in the spatial pooler. We're gonna keep it out. And the spatial pooler is going to be like a track. It's going to keep track of how much data it's seen. It might keep a cache of some things. But the cell state, the cellular state, is just simply an array of, it's just a data structure of weights. It'll be for each mini column, there'll be an array of indices of the potential pool, and a matching array of permanence values, that each one matching one of those cells. So the potential pool is just, all we need is an index and a weight for each cell that a mini column might have a connection to. Okay, so for each mini column potential connection, we need those two values. So I think we might not keep track of that in the spatial pooler. It'll just return that. That way we can keep these state arrays primitive. And that's sort of the idea, is because I want this data, I want these visualizations to be super close to the data. So I want to keep the data primitive, operate upon it using a spatial pooler class, potentially track what's been happening as we interact with that class in the class state. But the actual state of the cells is going to be primitive, and it's going to be kept outside, and we'll have that as a page level variable that all of these diagrams can then have an opportunity to display. And publish the source in the page too. Will I publish the source in the page? I don't know what you mean. You mean the code? The source code is all going to be open source. I mean, simple HTM is right here. I mean, so we're going to have in source, we're going to have spatial pooler. We'll probably create an algorithms folder with the spatial pooler, and you know, our building HTM system simply depends upon this project. So all of the clean HTM code is going to be in here. It's going to be heavily tested, and there will be no visualizations. And then the building HTM systems is all the diagrams. So when you show how the spatial pooler works, there are no snippets. Oh no, there will be snippets. Yeah, we'll put the snippets in. I'm just sort of driving down the whole visualization pathway first, and then we'll write the prose and put in the text, you know, just like I did with this. So it's going to be like this for encoding numbers, except a spatial pooler and lots of descriptions about what's occurring and all that jazz. Okay. So just thinking about where I might like to, okay, hey, Marty's on Discord. Where I might like to put tests. So I always want to start with tests. So let's create an algorithms folder here. And it might be fun to just write a few tests so that when we start the stream after the research meeting, we just have a place to start. So I was going to do that this morning, and I'm live streaming it. So that's what I'm going to do right now. So let's look at our tests. I'm going to create a new folder in Unit. We'll call it algorithms. And so the test structure, I'm using Chai. And I think that's it, which is sort of a behavior-driven. Is this? I'm not asserting anything. It's a behavior-driven testing platform for Node. And I don't know, I like the syntax. I like describing tests this way. It makes sense to me. So let's create in here a new file and call it spatial pooling. We'll call it spatial pooler tests, and we'll call the class the spatial pooler. So I'll just take one of my latest ones and copy paste, change some names. You're gonna live share this? Yeah, I can, sure. I think I already signed in, but that was last week. Okay. Here we go. I don't have a server to run, but you should be able to run tests, hopefully, just with npm run test. Okay, so let's change some names. We're not going to have a category encoder, but we will have something. We'll have a spatial pooler, and this will be in algorithms spatial pooler. Seems to be how I'm writing. Nope, no. So it would be like this. I don't know. Oh man. I'm having a hard time turning it all. So let me just change. Okay. So what we're going to do here, I like to keep examples around because I can never remember how to do anything. So upon spatial pooler instantiation, let's say that. So the things I want to test are the potential pools. Let's start with that. Let's just say potential pool is accessible. What do I want to do exactly? Let's say that. Upon spatial polar instantiation, it makes potential pools. Let's just say it creates a potential pool for each mini column. All right, that's clear enough, right? If it creates a potential pool for each mini column. All right. We are also going to test that it, just while I have this in my head, creates an initial permanence value for each cell in each potential pool of each mini column. Pretty explicit, right? But that's exactly what we're going to test here. Does that make sense? Do those tests make sense? Chai is good, isn't it? So we create a potential pool, and I'm gonna turn this into a describe here. And then we're going to further describe the tests. Let's just start creating something. So we're going to create an SP spatial pooler. Now this is going to create I'm going to create it exactly the way I want. So connected percent equals 100. All right, so this, if you can imagine, means that the potential pools will all be connected, or each mini column will be connected to every single cell in the input. All right, so this is going to describe a specific condition. So spatial pooler instantiation creates a potential pool for each mini column. I always do this, so just bear with me. I'm going to re-describe some of this stuff and narrow down these tests as I go along. Let's make this a little bit more granular. When you're writing tests, and unit tests, write them as granular as possible. Let's say spatial polar instantiation when creating potential pools. Okay, so let's write a function for that, and then this is going to be in here. When creating potential pools, first we'll say creates a potential pool for each mini column. I'm going to move this out here. So this will be the spatial pooler that we're using to test when creating potential pools. So first, I'm going to just write as many tests as I can with 100% connectivity. Okay, so we know certain things are going to happen here, and this is going to be seriously overly descriptive, but here we go. The connected percent. So now we've set up our test to test something. So we know we're going to create a spatial pooler, and we're checking the potential pools. When we tell it it's 100%, we're going to say it with 100% connectivity. Each mini column is fully connected to the input space. Okay. I know we haven't written a line of test code yet, but we're going to get there. Okay, so this brings up more questions, and as I go along and I'm doing test-driven development, it's pretty common that I will flesh out a bunch of tests and sort of define an API before I write any code. So that's sort of what I'm going to do here. Okay, so I know that this is sort of a way that I want to create a spatial pooler. I know I want to test that it, go through each mini column and make sure there is a potential pool here. It doesn't matter what type of connectivity it has for this test, but for whatever I put in here, it needs to depend upon 100% connectivity. So my only test in here is going to be probably that, and I'm not even going to write it yet. Actually, we'll do assert. I got to go grab the assert. Const assert equals require. I think I just do chai assert. Assert fail. Not implemented. All right, let me run this and see. I'd love to just keep running it. Make sure this fails. We should have one failing test. I probably broke something. Cannot find module. Oh yeah, there's no spatial pooler. So let's do that. In the source, I need a new folder called algorithms. And then I'm gonna take the structure of one of these. I'm gonna create a new file, spatial pooler. And I don't need that. Class, pooler, doesn't extend anything, doesn't do anything. Right, module exports spatial pooler. Okay, tests hopefully will pass, or fail once, one failing, okay. Yes, so we're failing because we didn't do anything. And I'm just to make sure I'm not missing anything, we're gonna fail. This is not gonna fail because there's no test there yet. And okay, so I'm gonna go here now. Creates a potential pool for each mini column, which is accessible. That's all I'm testing, which is accessible. So if I create an SP here, doesn't matter what the connected percent is. In fact, I'm not even going to give it a connected percent. It should just default to something. I should be able to, and now here's where I make the decision. How do I get the mini columns? Or how do I get the initial or the potential pools? So there's ways. Now we have options. How exactly do we want to do this? We could have So one thing is the potential pools don't change for the life of the spatial pooler. So perhaps we'll attach that to the state of the spatial pooler. And the spatial pooler, when instantiated, must be directly connected to an input space. Like, in order to create a spatial pooler, you have to know the dimensions of the input space that it's going to pool over. So in this spatial pooler, we're going to start really simple. Okay, so this isn't going to be the way it ends up, but we're going to start simple. We need to tell it the dimensions of the input. And we typically do this with an array, and I'll just say 100 things. And let's assume, at least initially, that we're only going to handle one-dimensional input. We're not doing topology and we're not doing local inhibition, because that's going to simplify everything drastically. So instead of this, let's say input count. I know this, eventually we're going to change this and we're going to have a multi-dimensional input, and it's not just going to be a count, it's going to be an array of counts for the different dimension sizes. But for right now, assume 1D input. That's the assumption that we're going to make. So all we really need to tell it is how big is the input space. Okay, so assuming one-dimensional input, no topology, no local 1D input, global inhibition, no topology. So those are all the assumptions that we're making by just defining this variable as just one count, is that 1D, global inhibition, no topology. So now, the potential pool should be accessible through the class instance because this is a state that will not change. So now I need to think about the, hey, maybe, now I'm thinking about React. So if I use the SP instance as a state container, I assume if something changes on it, actually the potential pools will not change, so it's okay to use this. But this is going to be per mini column. So what I really want to do is say get potential pools basically of every single cell, every single mini column, excuse me. So assuming that, I also need to be able to do this, I need to give it a size. And again, this also assumes 1D input because we'll just make it, I don't know, we can initially make this small. It doesn't matter. It doesn't matter. We'll make it 100 input and then 200 out, I don't know. So what we should get here, which is accessible. So assert, not undefined, is not null, something like that. Okay, so this is going to fail, obviously, but this is a decent test, I think, at first. So we're going to assert is not null, and then we're going to assert I think it's size or length. Is it length? Length of the pools is going to be the same as the size, so it's going to be 200. Pools 200. So let's put these as constants here. Input count. Actually, yeah. Input count 100. SP size equals 200. And we'll use that. So we know that we should have an array of potential pools, one for each of those, and then so pools for each. Assert. So here we have the pool. We need to make, well, this is just testing accessibility, which is accessible. It is accessible. It's accessible. Hey, this is flying by. I've got a stand-up meeting in like 20 minutes, so. Okay. Let me try and push through a little here. So first we're testing accessibility. I could probably add a little bit more over each mini column, which is accessible. Can I create an it? I think I can. It, can I do this? And contains potential pool indices. Basically, that's what I want. There's a typo and get potential pools. Thank you. Thank you. Okay, so I think maybe I can add this in here. I'm not sure. And it contains potential pool indices. It is accessible and it contains potential pool indices. So for each one of these, I should be able to say assert, well, I don't know what they are. Well, if I do 100%, which I did, I haven't done, all I'm testing is accessibility right now. It's fully connected to input space. Now I'm getting back into this. So this should be what I'm doing here, honestly. So let's test the fully connected part here. Okay, so we'll leave this here. We'll just say we'll leave this with which is accessible. And we're not going to assert null here. We're just going to assume that it works. And now I also need this bit. So now I probably want to lift this up since I'm going to lift this right here and put this in here. So we're using the same spatial pooler for all these tests so far. This one, okay, so now I can go through each of the P's. So the P's should be the same as that, and each pool should have a length of input count. Well, we'll do each. We'll do length of input count, and we're going to also say p dot for each. And it honestly should be just an increasing count. There should be one for each index. For each pools p, this is index. So we're just gonna call, well, I'm going to call this input index just to differentiate. Input index versus pool index. Okay, because the pool index is just the index of the P array, and the input index is the actual value of that index, which it should point back to the input space. So in this case, assert r same or r equals assert equal input index pool index. So this is only going to work when they're with 100% connectivity. As soon as we move this down to less than that, this will fail because we'll be missing an index, and this won't work anymore. Okay, so I'm going to start with that. Obviously this is going to fail, and we are not going to write the code for this. We'll do that this afternoon. But at least I have a test, and we have sort of a starting point, and I won't be like starting completely blind. So for the people who aren't interested in my casual chats in the morning and they want to just come see how spatial pooling works, we can sort of jump into this, and that's the plan anyway. Okay. So it does seem like there will be a research meeting. So what I'm going to do is I don't know what I'm going to do. I got 20 minutes until I have to be in stand-up. So I'm probably just going to work on a couple of things. I need to get my JIRAs updated for work. Whew. Okay, so now this is going to be class creation. All right. So just confirm there will be a research topic. A couple of things I need to take care of real quick. We're still doing... Someone's still mowing outside. I'll have to make some frequent trips to the restroom because I'm trying to drink a lot of water today. It's supposed to be good for sore muscles. I've got a really stiff neck today because I moved a ping pong table over the weekend. That's what happens when you reach 40. You become incapacitated simply by moving a ping pong table. To my credit, it was really heavy. Ping pong tables are really heavy. You're right, I shouldn't carry tables on my neck. Holy cow, you know, I think I was just doing this, like I was grabbing it and moving it like that with my son, and it did something really awful. And it didn't even hurt at the time. It didn't even hurt until like hours later. And then like the next day, could barely move. So I was just sitting here thinking about spatial pooler class and whether it should, how much state it should contain. And I know I was just saying maybe we'll keep the permanence values outside of the spatial pooler just so React can get to it, but I don't think we need to do that. We can keep it all in the spatial pooler and just create local, like page level globals that are primitive arrays. That's what will trigger redraws, and then on each step we just replace those with whatever we get from the spatial pooler, so that should be fine. Permanences and active column indices. There will be active column indices soon, but we're not quite there yet. Right now, the only state we're going to make accessible for the diagrams are the potential pools and the permanences. And the potential pools won't change. The permanences will change as the spatial pooler learns. And I think we can treat them all the same way. It just at each time step we run one more input through the spatial pooler, and then we just retrieve all of the primitive arrays from the spatial pooler as page level variables, and the diagrams will update themselves. I think that should work.
So do you need two arrays, or are you just going to use the permanence array and like undefined is a value for whether or not it's connected or not?
No. So I think all we need is one array. It would contain two things: an index to the input and a permanence all the time. That way we don't have to keep track of any input cells outside of the potential pool. That way that array would only contain connections, nothing that could never be connected. I think that's the simplest way to do it. We could also have an array that's the same size as the input and have, an undefined weight, and then not keep track of the indices, saying that the index is the same. That's the other way to do it. But I don't necessarily like having undefined values in arrays. It's hard, and it messes with diagrams when you do that. You have to make special conditions.
Right, but you could do that before you render that to the diagram. Like you take it out, strip it of undefineds, and.
Oh yeah, I could do that. But it lends itself better to the diagramming if I don't have to.
Mm-hmm.
So I think that's what I'm gonna do.
Yeah, the only reason I asked is because it tends to be better when you have like fixed lengths
Fixed lengths.
arrays, fixed length arrays when you're doing like on the GPU and stuff.
Oh yeah, performance-wise.
Yeah.
Yeah, you're definitely right about that. And just as a caveat, I'm not thinking about performance at all. It's just about clarity of expression, really, and ease of plotting. All right,
So is this you're only going to use this for the HTM stuff?
Am I going to use it for the HTM stuff?
Are you only using it for the building HTM system?
Yes, that's the plan.
Right.
The simple HTM is really just meant to be a reference implementation of HTM that goes along with this document. Other people could use it, and then, like I said, I'll probably go look at Paul Lamb's JavaScript HTM implementation, which is most likely a lot better and more efficient. But that's not my goal. Efficiency is definitely not the goal. It's just ease of display and understanding. I am going to turn my computer microphone off so that I can get into place at work with the double. So stand by.